SQL is an important component in the database management system course, and we introduced SQL under data manipulation using SQL topic. So, in this topic we will go through specifically the SQL language itself, but it will be useful in the stage of when implementing a database. So, after designing, when you go to implement, you will select a relational database, and a relational database you can manipulate only using SQL. Obviously, if you can use the graphical interface, but command base you need to know SQL. So, through this topic we will look at the SQL language and how you can use it to create your databases. So, SQL stands for structured query language, and it was first introduced way back in 1976 when IBM came up with a language which looks like an English type language with some English keywords to talk to computer and extract whatever the data. So, with time various versions of SQL was coming up by different groups of people, and as a result there was a need to standardize the language, and in 1986 the SQL was standardized, and SQL, the first version that we now call as SQL1, was emerged as a result. So, since then very frequently SQL has been evolved with more and more functionality and features been introduced, and then the database products also supporting them. So, with the enhancements, the SQL versions also various releases have taken place. In 89 an enhancement with integrity constraints took place, and then in 92 SQL2, which was a major revision, was took place, and then with these object oriented concepts coming up, and people were looking at how databases or SQL can work in a object base, having some other features what object oriented programming environment do support. So, for such requirements SQL was further enhanced, and various versions were introduced, and in 99 the SQL3 standards were introduced, and now basically we have this SQL 2003 standard. But for general database creation and use, you do not need to know all the features what has been offered through these new releases. So, you do not need to learn this language to the level of, for example, SQL3, but some extent to what the SQL2 standard offered is widely used and widely useful for traditional database applications. So, SQL itself is a database language specifically for relational databases. So, databases are based on different data models. So, for this relational model is what this language was built, and the relational model, as we know, came up with a theoretical background, and as a result for manipulating data, relational algebra, relation calculus, theoretical basis of manipulating data was introduced. So, based on this mathematical background, the SQL language was evolved, specifically looking at the declarative aspect of requirement. This SQL has emerged. So, already gone through the relational algebra concept. So, later once we do go through the SQL syntax to do similar tasks, we may also do a comparison, so that you can see how the SQL can easily provide you the information required, where you had to go through series of steps in the previous situation. SQL itself is not a database management system or a particular product. Obviously, there are vendor products which has used SQL as part of their product name. For example, Microsoft SQL Server. SQL is the name pronunciation used for SQL at the early days. So, earlier SQL was pronounced as SQL. Now, we use SQL when you refer to the structured query language. Also there are other versions like MySQL, also you have this term SQL. So, you should not confuse with respect to SQL is basically a query language as well as a language to create the databases as well, but mainly for manipulating data, because the creation part you would do only once and then you will access the data either through a direct interface or through your software programs what you have written to interact with your databases. So, it is not a programming language, but a comprehensive database sub language for controlling interacting with database management systems. Now, the language has capabilities to do the manipulation aspect. So, when you say manipulation, once you have created the database, so manipulation means retrieving and inserting new data, updating data and so forth. So, inserting, update, deletion, query are some of the frequent aspects. Query is the most commonly used. In addition, with respect to the security requirements, there are requirements for protection to see how you can protect your valuable data from unauthorized users. So, that aspect is also supported from this particular language. So, it is used primarily targeted for the end user requirement, especially with respect to querying, but you can also integrate that with your programming environment. The language itself is a non-procedural. So, in a procedural approach, you have to write step by step what is required and how to achieve that. Whereas, in SQL, we want to say what is the requirement and we say this is what we need, and then you are expecting the computer to produce that. So, the SQL is designed in a way that you will ask what is required and expect the output. So, that is what is similar to this relational calculus which was mentioned earlier. The relational algebra approach, basically you have to go through the process of how to get the data, where you will go step by step, and with respect to SQL you can assume that those happens internally behind the scene, whereas here you straight away get the information. And as mentioned, you can use as an interactive approach where you directly communicate with the database through your query interface through a command mode and extract the data or perform whatever required manipulation tasks, or otherwise through your software programs you will do that. So, for that your software program will be embedded with this SQL code. So, your SQL code will be put inside your application code, and then when you select a particular option, then that code would be issued to the database, and database would provide the information and show it through your software package. So, for that you need to know how to integrate SQL with the programming environment, and for that also there is support available. And here we are looking not with respect to going to the level of integration. Basically, for that you need to go to the programming aspect of that language as well, but SQL in general, how you write them. So, basically you need to just include that syntax within some part of your code, then automatically whatever required will happen. So, the which is done using this embedded programming approach. So, the role of SQL is basically to act as a database programming language, mainly useful for the database administrator, especially to create your databases, assign users and give privileges, and then for the applications, basically you will have a 3-tier architecture or 2-tier as a client server application, where database server will reside in one location, and then your applications executing from the client workstation will communicate with the system. So, for those purposes you will use the commands based on SQL. Obviously, databases we look at in this particular course as a centralized database where you have only one database management system, where the server manage all the data through one database server, but it is also possible to manage multiple database servers through a distributed database application. In such case, the same SQL is capable of handling that as well. So, it can be extended to a distributed environment as well. So, to interact with the relational database management system like SQL Server, Oracle, or MySQL. So, you through the interface or the application, you talk to the database product, and then that will talk to the underlying databases which stores data in form of tables using the relational concept. So, the relational concept, the definitions of tables, the table structures and things are stored in the database catalog based on how the relational model manage it, and the physical data would be managed in the databases using the structures defined in the user tables. So, as mentioned, the three types of SQL version that has evolved are like SQL 1, 2, 3, which were originally introduced in 86, 92 and 99, but in between there are other releases with certain enhancements, and for example, the recent enhancements include how to deal with certain object oriented features, like how to define your own data types and user defined domains and things which are not thought of at the early stages. Also, with this internet based applications coming up and XML taking a major role with respect to representing data in such environment, the SQL was extended to handle XML databases as well. So, the various enhancements has been introduced, but although these theoretically some of these standards are available, but you may not find all these features in a particular vendor product, because each one with their different releases will gradually introduce these features. So, if you go to a particular product, we will say something released in 2000, you will not find some of the features which will be handling with XML databases. So, as a result, you need to look at what each database product offer, and usually they will classify what is being provided with respect to the different SQL standard like SQL 2 and so forth, and within that also there is a separate classification, because you can provide certain basic features or to the full facility. So, to allow vendors to compete, that flexibility also has been provided. The idea of SQL is to be vendor independent. So, whoever the vendor, the same command should work, but that is how it is theoretically defined, but in practical sense there are certain issues because of the internal representation of data in various operating systems and how the various products do handle data, as well as certain keywords what has been already used by certain vendors. When the SQL use some of those to their keywords, then there are conflicts. So, there is ways of addressing it, but then there are certain deviations from the standards, but then for basic queries with respect to the end user requirements are concerned, generally it is compatible across almost all the products. So, as a result, only the expert level you may come across some of these issues, if there is, there are few, but not to a significant level. So, the advantage of using a generic language like SQL is it becomes platform independent, and once you write some code, then you can use those code in whatever environment, so that you change your development environment from one language to another, you can easily port your SQL code, and so your programmer skills, you learn SQL only once and then use for so many other purposes involving databases, whether it is whatever the vendor product of that database. So these are some of the advantages you gain through use of SQL. So now, in order to go into the SQL itself, we will first of all look at the database schema, because when you create a database, you have to start by creating a database schema, which will consist of the actual database, and then after that only you will go to creating tables. Then after that only you put the data, and then only you can retrieve. So we will have to look at in stages how to do various aspects. So just to briefly introduce the schema, which is basically defining the structure of that particular database required for that application, and how it is done. Again, there was a variation, because this is the first step of creating a database, and every vendor started with their own way. So initially there was this issue of non-compatibility with respect to this particular aspect, but then again this is not an end user activity. This is created by the administrator or the developers who does the creation of the database at the initial stage. So once you do it once, it will be there forever. So as a result, it's not necessary to worry about even if there are any incompatibilities. So early version did not include these concepts of schema as it, because they were mainly focusing on the database tables and so forth. But basically a particular application, if you look at a database application, it is used for many purposes. You can use employee data not only for a payroll, you can use for human resource purposes, insurance purposes, working for various other projects and whatever. So there you may have several database applications who wants to share this same data table. So to enable it to work in an effective manner in the same environment by one database server, you need to define various schemas and then share parts of it across applications. And so for that, this concept of schema is useful, although some may not use it as it is. So this concept is used in SQL to group tables, or if you have a set of tables, to say this set of tables belong to this schema. So schema of student application, or schema of an employee application, or a payroll application, or so forth. So to create such databases, basically most of the creation activity what you do once, basically the SQL use the command create itself, because it has tried to use same English keywords what you would use to express something. So and for easy use, all type of creation, what type of object you create, it starts with the word create, and it can be creating a schema, or creating a table, or creating a view, index and so forth. You will come across them later on. So when you are creating something, you have to identify it by a name and for what use, and obviously if you are worried about the security aspect, then you have to identify for who is authorized to use it. So in general, it can be referred as something like creating schema for a company, its authorization to a user called Smith. Now so these type of things would be done at the administration level, and sometimes nowadays you come across interfaces with graphical tools where you don't type the command as such, you just specify the names what is required, like who is the user and what is the name of the schema. So in that case, you don't see these commands typed as it is, but you can either go through a command prompt interface and do it, or use the interface as well. So for this particular course, we will not focus on the interface aspect, but also we will not go into depth of certain activities which you can do from the interface as well. So, just to get some idea about some of the creation activities, we will be introducing some of the keywords, especially creating tables and things, something that commonly use for so many other purposes. So, such things you should have some idea. So, along with this create schema, an example with respect to creating a table, and when you are creating a table, I mentioned it belongs to some schema. So, a schema can have several tables, and if an employee table belongs to this company schema, when you create the employee table inside the schema, automatically it will belongs to that schema. But if you are doing it separately, you have to link the two. So, how you link is you say the schema name followed by the table name, and you link the two using a dot. So, in SQL you will find many places where when you use multiple sources like table names, attribute names, and you want to combine the two, you combine with this dot, and so likewise you will come across similar syntax in this particular course learning this syntax. So, next we will briefly go through some of the basic elements of SQL. Now, to use SQL has to offer certain features, and these features can be grouped into different categories, and then within them, to do them you will have a set of keywords, and based on that you put them in a particular form, like you express something using a sentence. There is a specific sentence structure to specify how to create a table or how to access data, how to delete data, and so forth. Now, the basic structures, if you try to group them, basically we do three different type of tasks using SQL. One is the creation of creation activity, that is creation of schema or creation of tables, creation of indexes, and so forth, which is task of an administrator. It is a more or less a one-off task, and the data definition language is the name we have given for that, because we are defining the data structures using this component. So, all the commands belonging to defining, we group them as the language components of the data definition language. So, using that you can define your database structures. So, after you define the structures, you can add data, modify data, and so forth. So, those are the typical manipulations one would do using a database. So, end user's task is that, and that is done through the data manipulation language, which is the referred as DML. Then obviously, I mentioned there is some requirement for security, who can use which data and so forth. So, to focus on the security aspect as well as how to handle multiple users request simultaneously, we need another aspect of the language, and that aspect is called data control language. So, using that we will control who can access which data as well as how to synchronize the transactions executed simultaneously. Now, our main focus will be going into depth of this data manipulation language, which is what the end user will use. So, if you look at the database architecture, the top level from the external view, the user interacts and or the program interacts, and for that what we use is the data manipulation language. So, that is the main most commonly used part of the SQL. But to create the conceptual schema, the middle layer of the database architecture, you need to have this data definition language, and through that only we can create our database schemas, the tables, and that part is done through the data definition language. So, once you do that through the software, the physical schemas and things would be created, but that gets activated only through the commands what you execute through the SQL syntax. And for various controls, as I mentioned, we will use the data control language. So, we will look at briefly some of the syntax of data definition language, then data manipulation language, and data control language, and then later we will look at each of them in detail and see how you can do some of the tasks. We will not go through every syntax, but some common things would be explained. And to get familiar with this type of things, you have to use a computer, you have to use a database, you have to try these commands, then only you will actually learn. You cannot learn by just following this without any practical aspects, because like writing a program, when you write, you put it in the wrong order, you come across syntax errors. Similarly, the same experience you will experience by using a database software using SQL, and that is a requirement to know this language well. So, with respect to the data definition language, as I mentioned, the create is the keyword to create the objects. So, you can see in this slide we have a create table, a create view, create index, create cinnamon, and so forth. So, those are creating various type of objects, and we will look at some of them at a later point. So, I will not go into detail, but along with that we have also put some few more other keywords. We have a drop table, drop view, drop index. So, whatever you create, if you want to remove, we refer it as drop. So, create is using the create keyword, removing is using the drop keyword, and what it will do is it will drop the structure from the database. And then there may be a requirement to modify or alter certain structures. So, alteration is done using the keyword alter, and for a table structure we will need to do alterations by adding some data items or removing unwanted data items. And certain things you may find it altering is a difficult task, it may be easy to drop and recreate. So, for such cases you do not have the alter option. Alter is generally applicable only for altering the table structures, and for that again nowadays you have the interfaces to do it instead of going through the SQL commands itself. So, the most common category, as I mentioned, is the data manipulation language component, which is what is used by the end user, and the end user's task is to add the data, which may be a data entry operator's task, but the data entry operator may not know SQL to do that, but for that you will have an application with some interface to add the data. So, when you save the data, the backend will execute the SQL code related to inserting, and then the data will get populated in the database. But for normal user like a manager who wants some information to know the current status of some application, then he has to issue an SQL statement. So, if you are competent SQL user, then you may have the flexibility to get whatever type of information you need. You can just type this the SQL syntax and obtain it. Otherwise, again the programmers have to write various SQL commands and have it as menu options. So, if you go to that level, then you are fixed to viewing a predefined set of information all the time through your application. But for dynamic decision making, that alone is not adequate. You will always come up with what if options and so much of other options you may want to look at, and for that it is necessary to know some SQL, especially the select statement. So, with respect to the person who is going to be in the software engineering area, then this is anyway part of it, because any application using databases you will have to use SQL. Otherwise, you cannot talk to a database, a relational database, without this language. So, the other two commands is to remove data. We have delete. So, delete is removing instances what you have added earlier through the insert command, and then update is to do a modification. So, those are the 4 main manipulation tasks, and then with respect to using them in application development environment, you have to use few other keywords of how to open a table or how to make connection with a table, and how to manage transactions. You may have to do some controlling aspect with respect to manipulating data through a program, and for that purpose you may need some other keywords. We will not go into those details as part of this course. You will experience that when you go into the proper development aspect. So, the course is concerned, we will focus mainly on the 4 data manipulation aspects what was mentioned. And the last category of the 3 categories mentioned is this data control language. So, as mentioned, data controlling focus on the security aspects, mainly to identify which user can use which data. So, when you store data in a database table or set of tables, so we will find like all employee data is in the employee table. Now, we do not want everybody to who wants to access data to access all the data. That means, you do not want to show all employee data, maybe your department's employee data you may allow to look at. Also, if you look at certain characteristics, some will have information like the age of the employee, salary of the employee and so forth, which are sensitive data which you do not want everybody to know. So, in such cases we must have a facility where one user can manipulate employee data like name, telephone number and whatever and access data without seeing the existence of certain sensitive data. So, such things are possible through these specific commands like grant, revoke. So, granting is basically providing the privilege, and later on if you want to take it out you will use the revoke keyword. And to manage multiple transactions simultaneously, because in a database the advantage is although you have all data in one server, you can have thousands of users across a network trying to retrieve data from the same database, and it is possible to do that. And to manage those transactions especially with respect to updating and so forth, we may use this commit and so forth. So, we will not go into details of them, but then these are part of the commands available with respect to this SQL basics. So, the main class categories is what we introduced, and within these categories you will have a series of other sub keywords. Now, when defining SQL, one is to define the structures as the appropriate standard and well as the associated keywords. So, the standards are linked with the standard key ANSI ISO standards, and through that there is a set of reserved words which you should not use for other objects. For example, when you say create is to create a table, you can't use a object called create, then the data system will get confused. So, as a result there are set of reserved words which you cannot use for your other objects, like you may use employee, student and so forth, because they are not reserved words, but words like I mentioned like insert, select, update, those are reserved words. You can't use those words for purposes of describing a table. So, you should have some idea about the keywords, especially when you try to use them, you will get familiar with them and have a good understanding about them. So, a brief listing of some of these keywords are what is listed here. So, this does not cover all the keywords, but with time you will get familiar with most of them, and I do not advise you to go through one by one, but when you use for example select keyword, with that you may use the max keyword or min keyword, null keyword and so forth. So, through that process to get familiar with the keywords, and when you use practically you will automatically get a feedback from the computer indicating that it is a reserved word. So, with that we have basically introduced the SQL, the standards, and what SQL is, how it has been structured, and as the next subtopic within that we will look at how to create a database, followed by how to later on manipulate it. Next we will look at about how to create a database, and now mention we have to start creating a schema to put your all the tables together, and so schema will represent one database, and you can have several schemas within managed by one database server. So, in a particular typical application you may have to just create one database, and that would be your schema as well. So, certain application you may not have these two as two different tasks, you may do one of them, and later when you want to use it especially through your application, you will have to see how to connect to this database, how to open respective tables where you have the data, and then you issue your commands to the database after that, and once you complete the task you will close the whatever the tables you have opened and close the session, so that you don't interrupt with whatever any other user would do with the same database. Now, when you are using the databases simultaneously, more than one person will want to given time. So, you need to open tables in a way that multiple users can share the same data. So, when you have an employee data set, if somebody is changing the employee data, if the simultaneously if another person change, then you have a problem, because you will someone's data will get lost. So, the database management system have mechanisms to block such things happening. So, it has various locking mechanisms and things applied, and we have way of managing concurrent use. So, we will not go into such details through this particular course, but just to give an idea that start the process you will like creating the database schema or database itself is what you would do, and after that is what you create is the tables. So, for all of them these tasks you use the SQL commands, and so other than the tables in the design process you will see you normally have entities, relationships, attributes and so forth. So, when you create a table structure, the entities and the attributes becomes a table structure when you define a table, and then using various constraints you can establish the relationships and whatever other requirements, and so there are various ways of achieving it. So, we will look at some aspects of it through this lesson. So, as mentioned, creating is done through create, removing objects are done through drop, and altering is done through alter, and so those are the three types of data definition language, the main components. So, with that we will associate a table or a view or index and so forth. So, we will look at each of them separately, and all of these objects relates to the physical creation of certain aspects of structures required to manage your data. So, when you issue these things, some physical creation in the on the disk will happen as a result. So, as mentioned, the creating a database or schema you will use the the create command. So, for creating a database we will call as create database. So, the idea is to allocate the required space you want to reserve for that particular database, because with time the database will grow and you may want to make sure that you have some working space when you want to manipulate data. So, as a result the database reserves some disk space to store the data as well as for other activities what you may do when using the system. So, the initial allocation of storage space to contain objects is what is done here, and with respect to the standards, originally this was proposed, but then later in SQL2 actually it was taken out because the schema took over the task of doing that particular activity. So, the create schema defines a portion of a database, and particular users who can access to that portion also may be defined, and obviously you can pass your user rights to any other users depending on whether you want to share your data with others. So, usually when you create, the person who creates becomes the main owner. So, if you get the system created through an administrator, then he becomes the main owner, and then he will pass the ownership to others whoever wants to use it. Then I mentioned about distributed systems also may use the databases. So, you may need to define where each database server is located, and again you can use the same create command with the keyword location for that particular purpose. The create table is what we are going to look at in detail, followed by briefly introducing the create index. Indexes are nowadays again automatically happens, and you can obviously define them as well, but nothing much to look at because its main task would be the creating table aspect. Later on in the course, we will look at the create view, because create view is linked with the data manipulation, the retrieval SQL select statement as well. So, without knowing the select statement, it is not possible to introduce the create view, because create view is a logical way of looking at data, whereas the create table is a physical way of looking at your data. So, physical way means physically there are data, whereas logically means there are no data physically, but you look at the information like as it is, the data is there. So, to see data as it there, that means it has to be actually somewhere else. So, under a physical structure there are data, but those data are mapped to some logical structures using views, and through that you supply the data. So, there are no physical data attached to the view definitions, but the data is available with the physical table structures is what is meant by that. We will come back to that at a later point. So, we will briefly look at the table structures, how to create tables, and then later on we will briefly introduce about the syntax to drop is straightforward, and little bit on how to alter the structures. Now, the create table you will do only once to create a particular table, and so if the table structure is already there, you have to drop it before you can recreate it. So, that is something you need to know, because when you are doing in a practical manner, you want to try something twice. So, create table is something it will not allow you to try twice, because it will tell it is already there. So, in that case you have to drop and retry. Now, the syntax is create table whatever the name you want to give. So, if it is employee database, your table name will become employee. Then the table structure, basically table have a set of columns and rows. So, rows are your actual data, columns are the different attributes that you are going to record under this table. So, the characteristic of the data are defined under different columns. So, you will have for employee, you may have an employee name, address and so forth, which will be different columns. So, these columns has to be defined in a way that a database can handle a set of names, set of addresses, set of telephone numbers and whatever. So, we will look at how to define columns, and later we will look at how to define various constraints. So, constraints play a main role in databases, because it allows you to manage the data and enforce the consistency of the data without you having to physically check each and every time. Once you define the rules, the system will do it for you. So, if you define it first, then you can just allow the data to evolve on its own, and you can be satisfied that certain rules will always be satisfied, and you are minimizing the probable errors that could take place. So, various type of constraints defined as primary key, foreign key, unique, check constraints are possible. So, we will introduce them as well once we go through these column definitions. So, for each form there is a set of keywords which all of them are used together to construct the complete create table statement. So, for a column definition, the two components are there, two main components, one is the column name, the other is the data type. So, you specify the column name like the employee name, a data type means what type of data can this employee name can store. So, and then there can be some optional constraints in the same definition, or you specify the constraints separately like primary key, foreign key, uniqueness and so forth. So, for primary key we are given a keyword called primary key, for foreign key we are given a keyword called foreign key, for uniqueness we are given a keyword called unique, and for check constraint we are given a constraint called check. And in addition there is also constraint called not null, which we will also introduce subsequently. Now, when defining column names like you use for programming, you can use certain concepts of naming variables. Similar rules applies for SQL data types, the column names, and then like in the programming languages you may use a data type to indicate that this variable is of this type of characters or integers or real numbers of type date and so forth. So, commonly used types are defined as basic data types, and the types available is, we have a type called char or character, which is defining a fixed length character. So, if you say char of 10, that means it will reserve 10 characters space to store up to 10 characters. So, if you type a 5 letter word, then it will put 5 blank spaces and fill the 10 characters, because we have allocated a space of 10. Then int or integer is to manage whole numbers, it can be positive or negative. So, like 10, 15 or whatever. Now, when you talk about whole numbers, you can talk about small numbers like 10, 20, or larger numbers like 1000, 100,000, million and so forth. Now, when you go to large numbers, the way the data are stored internally, you will require more bytes to represent this data in the internal system. So, the storage capacity of these data items will vary depending on how many bytes are used to represent your data. So, for characters, for one character 1 byte. So, when you say 10 character data item, then automatically 10 bytes of data will be used. But for when you say a number, it depends on the range. So, basically numbers you have to manipulate with 2 to the powers, and then you will determine whether it is a 2 byte integer or a 4 byte integer and so forth. So, the maximum number you can store will vary depending on that. But nowadays the storage basically goes in gigabytes, and so as a result these small bytes people do not worry about. But when a database grows, when it takes a lot of time, that means it is reading each byte of data for your request. So, when you manage it efficiently, your performance also will be improved. So, later on you may feel that, see that it is important to worry about those tiny details, but with respect to this course you do not need to go into that level. Then there are numbers with certain number of decimals, or which are defined as numeric or number, decimal, DEC, float and so forth, all refers to similar type of numbers. And again all these names are available because certain programming languages, certain products use these terms. So, for convenience all these options has been included as probable names. So, you may find some products recognize some data type as decimal, whereas another may recognize as float or something like that. So, there can be such differences, which is one of the examples of a difference you may come across different vendor products. But as this is done only once for application, it does not becomes a big issue. So, for numbers with higher precision is required, you may have single precision is the usual form, you may otherwise have double precision. Then there are, other than these basic data types, using the basic data type you can have other extended data types. For example, using a collection of integers in a particular form, you can define a date, where the first part is the day, month, year. So, there are the types defined as date or time stamp, where date and time both can be managed, and then there are values, numeric values. You may deal with currency, which is up to 2 decimal places, and then some strings you may want to have a variable length. You do not want to just pad with blank spaces if there are, if the word ends at a particular point. In that case, you may use a variable length or varchar data type. So, likewise many data types are available, and to manage unstructured data, images, web pages or other language characters, Sinhala, Tamil and so forth, you need facilities. So, all these are possible in the data environment, and various types are available for such purposes. So, in addition to that, you can define your own data types as well, using another feature which has come with these enhancements of this SQL language. So, so those are part of the column definition. You need a column name and a data type. So, data type was what was mentioned as integer, real and so forth, and to define a table, in addition to that, you also need to define your constraints. So, for that you have to understand what are the constraints. So, I will first introduce these constraints so that you will understand them, and then we will link them to the table definitions. So, the constraint as mentioned is mainly to manage the integrity of the data, and it will be used to validate data when you add new data, change data, and ensure your consistency of the data. So, invalid data added to the database, it will try to minimize such things, so that if you are entering an exam mark and you know the mark is between 0 and 100, you can give a condition which will avoid somebody entering 120, which is out of the range. So, if you do not define the rule, then the database will take any number, because the data type we define as integer. Integer can have even 1000. So, so invalid data of within out of the range can be easily checked and eliminated. So, integrity, data integrity and constraints are basically defining rules to handle such requirements. In addition to that, as we are handling several user requests simultaneously, there are many other issues as well, which are also handled by the integrity subsystem. Basically, a database management system have various subcomponents within the system, and integrity subsystem is one component, security subsystem is another component. So, each of them will deal with these aspects. So, I will not go into detail of certain aspects related to the create table is what we are going to look at this stage. So, under different type of integrity constraints, one type is called not null, used to define the requirement for that data. So, required data, that means you must enter some data, and for that data field you will say not null. For example, if you are identifying, we will say an employee by a name, you must have a name. If you somebody do not enter a name and try to put the other details of an employee, it becomes meaningless. So, to force somebody to enter the required data, you will use the keyword not null, then the database will not allow you to proceed without that data. Then to check for a particular validity of data, like the mark between 0 and 100, you can use this check constraint using the keyword check. Then in the interrelationship diagram, we were looking at entities, relationships and so forth. So, with respect to the entity, which becomes a table with respect to the relational model, the entity instances identified through the key field, which is the primary key, and the same primary key is applicable here as well, and it should have some value. So, the two together is what you call as entity integrity, which is defined using the keyword primary key to define the uniqueness characteristic, as well as there should be values are required. So, not null is also part of it. Referential integrity is defined through a concept called foreign key. We will look at that in little bit detail in a subsequent slide, and that is required to establish the relationship between entities and to ensure consistency across various tables or various entities. Then there are various other rules which cannot be expressed using those 4 types. So, to enable a user to define whatever requirement, for example, you may want to tell that in your database when you enter the salaries, you can't have a employee who is not the manager getting a higher salary. Usually manager must have the higher salary. So, in that case you may want to define a rule where it will automatically check and ensure manager will get the higher salary. So, likewise you can define various rules. Sometimes various transactions happen in a database and you can't be looking at what is happening all the time. For example, if somebody withdraws, we will say 100,000 from account. Now, in your transaction usually the procedures say you have to get approval from the manager to go through a transaction of that nature. So, if the database alert the manager through the database triggering particular message, then when the manager sees the message, if he has already authorized, then he knows it is happening the way it should be. If he has not authorized, then he knows immediately something unauthorized has taken place, then he can take immediate action, so that you are in a position to manage whatever happening through your information system with the proper control required. So, for such purposes these triggers and things are provided, and all those are constraints. And with the referential integrity, I will briefly describe some consistency aspects handled through cascade, restrict, set and set null and so forth. Now, null is a special value with respect to a database. Now, normally when you put a value to a particular column or data item, you put a value like a name or a number or salary or whatever, you put some value. So, sometimes you do not have something to put, it is something like sometimes it is not applicable, like you may ask someone, are you married or not. So, if it is not married, then no point asking what is the spouse name. So, that means it is not applicable. So, similarly there can be a situation, it may be applicable value, but you do not know the value at that moment. So, in such case you want to skip that and go. Now, in the database it is not possible to just skip, database has to store something for every data item. So, in such cases, to handle cases where there are no values, this special value called null is introduced. So, null is a special value which is not visible, but with respect to data storage in the database there is something there. So, null values allows a systematic way of handling missing or inapplicable data in SQL, and as mentioned it can be used to deal with missing data or data not yet known and not applicable. So, with respect to this null, it is not a real value, it is a special value as explained before. So, null values require a special way of handling, because when you retrieve data, some data comes with null records having null values. So, when you do a count, you have to know whether you want to count with nulls or without. So, you have to have some idea about handling that when you are dealing with summaries for averages, sums and so forth. So, usually null records will be ignored when you say sum and average and so forth, but then if you are counting employees where some other values are null, then you have to see know how it is handled or how you wanted to handle and so forth. So, those you can try out when you go to the practical level. Also again there are also some software can differ with others the way it is